So let's go over here and do our little scratch work. So nitrogen, we have 2 times 14.0. All right, because when I look on my periodic table, the atomic mass of nitrogen is 14.00674. Let's see, the one in the book that you may have, 14.007. Yeah, but they both round to 14.0, so that's fine. Okay, so there's 2 nitrogens, so that's 28.0. Oxygen, we have 5 times 16.0, and that is equal to 80, I believe. Oh, let me do the calculation real quick here. Yes, 80.0. Okay, and when we add those together, we should get 108.0 grams. All right, so that, my friends, is the molar mass of dinitrogen pentoxide. Okay, so if we have 108 grams of this compound, you can be assured that we have 1 mole. Okay, but now what we want to know is how many grams of this compound would we have if we had 1.73 moles of it? Well, just kind of using your common sense, you know, if 108 grams is equivalent to 1 mole, then I think you could reasonably estimate that, you know, it's not going to be quite 2 times this, right? So 2 times this would be 216. So, you know, 1.73 is going to be, I don't know, like 190 grams, I'm guessing. So let's do the calculation and see how close we get. Okay. So to set this up, we say, you know, number of grams equals 1.73 moles times, and then we set up our conversion factor. We want the grams on top, right, because that's what we're calculating. We want to cancel out moles, and that's 1 mole. Okay, so take your handy dandy calculator, multiply 1.73 times 108, and I get 186.8 grams. Okay, and again, since we have 3 significant figures in the information that we're given, we should, you know, technically only keep 3 significant figures in our final answer. So that's 187 grams. Okay, let's see if that's close. Yep. Okay, so I've got the answer key over here just to make sure I'm on the right track. Okay, good. We're doing good. Next one, E, 0.658 moles of calcium phosphate. Just getting my timer up here so I keep track of the time. Okay, so calcium phosphate. I gave you the formula. I probably didn't even have to do that, but you can see that there's 3 calciums and then 2 phosphate groups. So we've got to do a little work here calculating the molar mass. Okay, so calcium, when we look that up on our periodic table, I see 40.08. So if we round that to tenths place, that would be 40.1, right? So calcium, that's 3 atoms of calcium weighing in at 40.1 grams. Okay, and then we have, how many phosphorus atoms are we going to have? Well, you've got a 2 subscript and then parentheses, so that 2 multiplies through, so we have 2 phosphorus atoms. So that's 2 times. Okay, let's look up phosphorus. 30.974. That rounds up to 31.0. So 31.0 is just fine. And let me go ahead and do my multiplication while I'm doing these. So that's 120.3. This would be 62.6. 16.0. And then let's see, we got oxygens. How many oxygens? That's 2 times 4, so that's 8 times 16.0, and I believe it's going to be 128. Let me make sure. 8 times 16, yeah, 128. 128. Okay, and then add everything up. We get 3. That's 10, carrier 1, so that's 9, carrier 2, and that's 4. Okay, 410. Let me just triple check that, make sure. So I'm kind of like doing this right along with you. Whoops, yep, I thought I made a mistake. Okay, my spider sense went off. I sensed danger. Okay, 310.3 grams. That is the molar mass of calcium phosphate. So, by the way, what is the representative particle for this compound? Okay, if you said formula unit, you are correct, because this is an ionic compound. If we want to have Avogadro's number of formula units of calcium phosphate, you're going to have to weigh out 310.3 grams. All right, so just trying to reinforce how all this fits together. All right, so let's get down to business. Number of grams equals, we put down what we're given, so that's 0.658 moles times conversion factor. We put molar mass on top, 310.3 grams over 1 mole. Moles cancels, and let's take 310.3 times 0.658. Excuse me. Okay, I'm back. I thought I was going to die for a second. I swallowed the wrong way. Good thing this has a pause button. All right. Now, if the molar mass is 310.3 and we only have 0.658 moles, that's about 2/3 of a mole, right? So again, if we put our common sense hats on, we should expect the final answer to be around 2/3 of 310 grams, which would be about 200 grams. So let's do that. 0.658 times 310.3, and I get 204.2 grams. Oops, that's 204.2 grams. All right, and again, 3 significant figures, so we could just round that to 204 grams, right? Okay, let me just double check that answer, make sure we're on the right track. Yes, we are doing well. All right, so that's a series of mole to mass conversions, right? So what we did was we were given a certain number of moles, and our task was to convert that to grams, and I think we're doing great. All right, now let's shift gears. And this time, I think you can see that we're being supplied with the mass of each of these compounds, and our mission is to convert the number of grams to the number of moles. So we're just going to go the opposite way. We still need to figure out the molar mass for each of these compounds. But if you're kind of thinking ahead a little bit, I think what you'll realize is when we put this into the calculation, we're going to flip the conversion factor, and this time we'll have mole, 1 mole on the top, and then the molar mass on the bottom, and that'll allow us to make the transition from grams to moles. Okay, sodium bromide. Sodium 23.0. Let me write the chemical formula first. Okay, so that's 23.0, and there's only 1 per formula unit. Bromine is 79.9. 79.9, and when you add that together, let me plug this in. 102.9. Okay. Sounds like an FM station. 102.9 grams. Okay, now we are ready for the calculation. So this time, what are we trying to find? That's right, the number of moles. And that's going to equal, here's what we're given, half a gram, 0.5 grams, times our conversion factor. This time we want the 1 mole on top divided by the molar mass. Okay, and let me plug that in, 0.5. And I think if you're kind of anticipating a very small number of moles, like a number that's much less than 1, you are on the right track. That's what I would expect too. So 0.5 divided by, don't forget this is divided by 102.9 equals, oh my goodness, my answer is in scientific notation. Let me put it down here, 4.86 times 10 to the negative third mole. Okay. There we go. Okay. Let's try B. Let's do B. Okay, I have to erase this, sorry. Gotta make some room. Let me make some space here. Okay. Excuse me. Magnesium nitrate. All right, magnesium. What's magnesium? That is 24.3. 24.3. And then we have 2 nitrates. Okay, so that's 2 nitrogens. So 2 times 14.0 equals 28. And we have 2 times 3, 6 oxygen atoms. Okay, so that's 6 times 16.0, which, if memory serves, is 64. 6 times 16. Oh, what am I talking about? 96. 4 times 16 is 64. All right. What's the total? 96 plus 28 plus 24.3, 148.3 grams. Okay, so 148.3 grams is the molar mass of magnesium nitrate. Now, let me grab some more space here. Number of moles equals what we're given, 13.5 grams. 13.5 grams times 1 mole. So here's our conversion factor over 148.3 grams. Okay, grams. I didn't show you the cancellation on the last one, but grams cancels. And 13.5 divided by 148.3. And that gives us 0.091 moles. Okay, excellent. Let me double check here. Scroll down. Good, good. All is well. Okay, next. Make a little bit of space. Oops. Actually, I'm going to have to sign off and do a part 3 because I'm bumping up against my 15-minute limit. Okay, see you on the next one.